We have to start with a number. I mean, we just have to.
There's no way around it.
$20 billion cash. That is the price tag for what we are analyzing today. Nvidia's strategic move to acquire the core IP and the talent from the chip startup Groq.
And if you've been following Groq at all, you know that prices, well, it's a massive premium.
Massive. It's nearly 3 times their last private valuation, which was, what, around $6.9 billion.
Exactly. And that $20 billion, it's more than just a price tag. It's really a thesis statement. It's Nvidia declaring that they plan to own the entire future of AI compute.
So this deep dive, it's really about understanding that huge strategic shift that's driving this price, a shift that, analysts are all calling the inference pivot.
That's the term.
Our mission today is to unpack that pivot.
Yeah.
We need to understand why Groq's technology, which is designed for really one specific part of AI processing, was worth that kind of premium.
And to do that, we first have to, define the battlefield. Because AI compute really has 2 very distinct halves.
It does. Let's use the classic analogy. Think about how you create an AI in the first place, like teaching a large language model to talk or teaching a computer to recognize a cat.
Right.
The first half is training. This is the big, upfront, brute force phase. You're feeding a system this massive data set, all the internet, basically, and the model learns a new capability from all that data.
And that's where NVIDIA's GPUs have been king for years. They just excel at that kind of massive parallel work.
But once the model's trained, that's when the real-world value starts.
That's inference. Inference is applying that trained skill to new data. It's asking the model a question and getting a response back, or showing it a new photo and asking, hey, is that a cat?
And this right here is the core idea that justifies the whole $20 billion deal.
Mm-hmm.
The battle for AI dominance is moving away from training, where speed is measured in days, to inference, where speed is measured in
microseconds. And this deal is about NVIDIA securing the world's fastest inference architecture, full stop.
And securing it urgently, it seems.
Very urgently. The market dynamics are changing faster than anyone predicted.
Okay, let's unpack that urgency, because that's where this valuation really starts to make sense.
The core driver here is market revenue. We are right on the cusp of what the industry is calling the revenue inversion.
The revenue inversion. So what does that mean?
Well, current projections show that by 2027, inference revenue is going to surpass training revenue globally.
Why is that?
Because once you've trained, say, 100 massive foundational models, those models are then running inference operations constantly. 24 hours a day, 7 days a week, serving millions of users, asking questions, translating text, driving cars.
So the economic focus just completely shifts. For training, you need raw power. For inference, you need ruthless efficiency.
Ruthless efficiency. And that means minimizing 2 things. Cost per token, so how much it costs to generate one word, and maybe even more critically, latency.
Latency being the delay, right?
Right.
The pause between your question and the AI's response.
Exactly. And latency is the enemy of user experience. It's the enemy of real-time automation. This is why NVIDIA had to move. They're grabbing Groq's specialized technology, the language processing unit, or LPU.
The LPU.
Specifically to counter the rise of all these other specialized chips ASICs, application-specific integrated circuits that competitors are building just for low-latency inference.
So if they didn't neutralize this threat, they risked losing that whole high-margin inference market.
They risk being outflanked. So that $20 billion price tag, it starts to sound less like an acquisition and more like
insurance.
A dominance tax. That's what investors are calling it.
It is absolutely a dominance tax. You have to ask yourself, if Nvidia already controls, 80–90% of the AI market, why pay a 3x premium? Why accept a valuation that's, roughly 14 times Groq's pretty modest projected 2026 revenue of $1.4 billion.
It does seem like overkill.
Not if you look at the strategic goal. Nvidia isn't paying for Groq's current revenue. They're paying $20 billion to guarantee their software ecosystem and their role as the essential AI partner for the next decade. Without Groq's speed, that Latin inference would be at risk.
Totally compromised. Customers would eventually start building their own chips or moving to dedicated ASICs. This was a preemptive strike. And to really get its value, you have to look under the hood at the LPU architecture itself.
Okay, and this is where it gets truly fascinating for anyone who's wondering how these unbelievably fast models actually work on the hardware. What's the technical aha moment here? What makes the LPUs so disruptive compared to, say, an H200 GPU?
It all comes down to traffic management.
Traffic management, I like that.
A traditional GPU, it uses a parallel architecture. The technical term is SIMMT, single instruction, multiple threads. Think of it like a gigantic, complex orchestra.
Right.
The GPU conductor has to constantly manage hundreds of different sections, all the threads, and make sure they're all in time and getting the data they need. That coordination, that's what we call scheduling overhead. It just slows things down.
So the GPU is great for training, which is like running a million identical calculations at once, but less efficient for inference, which is more of a sequential task, right? Like generating one word after another.
Precisely. The LPU flips that whole paradigm. It uses a data flow architecture, or SIMD. So instead of a chaotic orchestra, data flows through the LPU like an ultra-efficient assembly line.
So every station on the line knows exactly what its job is.
And when the next piece of work is arriving, this design just inherently eliminates that scheduling overhead that plagues traditional chips.
That is a huge conceptual shift. The old chip waits for instructions. The Groq chip expects the data to flow through it.
Yes, it's built from the ground up for speed and predictability, but the architecture is only half the story. The memory difference is what really solves the biggest physical bottleneck for inference.
Let's nail this memory bottleneck because it's so important. A top-tier GPU, even the most advanced ones, they rely on HBM3E high bandwidth memory, which is off-chip.
And off-chip is the problem. Think of it this way. Your chip is the super fast brain, but all the information it needs is stored, miles away in a library.
Okay.
Every single time the chip needs to generate the next word, it has to make that commute to the external memory and come back. That travel time, that's latency, and it adds up incredibly quickly.
And the LPU solves this commuting problem. How?
By putting everything right there on the desk. Groq's design is SRAM-centric. It uses ultra-fast static random access memory that is integrated directly on chip.
So everything it needs is right there on the same piece of silicon.
Exactly. This eliminates that commute, which means massive throughput and, basically instantaneous LLM responses.
So what's the real-world impact of that for a developer or a user?
It means a drastic reduction in latency. A traditional GPU serving a chatbot, it usually needs to do something called batching grouping user requests together to hide the latency, and they operate in the millisecond range.
That's the slight pause you sometimes see before a chatbot starts typing.
That's the one.
And the LPU.
The LPU operates in the microsecond range, and that leap from milliseconds to microseconds, that is the difference between a slightly laggy assistant and a system that's capable of true real-time responses for mission-critical stuff.
Which brings us to that final key technical point. Software determinism. Why is guaranteed predictable speed so important?
It's just non-negotiable for serious applications. The LPU's compiler handles all the timing and execution. It defines exactly when every piece of data moves, so you get 100% predictable performance. Determinism.
And why does that matter so much?
Well, think about a high-frequency trading algorithm or an autonomous surgical robot. If performance suddenly fluctuates by just a few milliseconds because the system is busy, the mission fails. It's that simple.
So, to put a bow on the tech, the LPU is just built to bypass the biggest traffic jams in traditional GPU design. And this is what Nvidia needed to neutralize. So let's pivot back to strategy. If the LPU is this disruptive, why didn't Nvidia just try to build their own? Why pay the $20 billion?
This is the tactical masterstroke. It's all about expanding their moat, that big wall around the Nvidia kingdom. The rationale is really threefold, starting with defense.
Defense.
Groq was the most credible architectural threat to the entire CUDA software ecosystem.
And CUDA is their foundational advantage, right? It's the software framework that every AI developer has used for years. It's a huge pain to switch away from it.
It's a massive switching cost. So if Groq's LPU had gained wide adoption, forcing developers to write code for a non-CUDA system, that would have fractured the market. By absorbing Groq, they neutralized that threat and forced the tech to live inside the CUDA ecosystem.
They bought the threat.
They bought the threat and the brain power. They didn't just get the tech, they got the key engineers, the founders, Jonathan Ross, Sunny Madra. They're all joining the Nvidia AI factory now.
Which leads to your second point, I assume.
It does, vertical integration. By bringing the LPU in-house, Nvidia can now offer its enterprise clients a seamless, high-performance pipeline for everything, from initial training runs all the way to instantaneous final inference.
All within one Nvidia ecosystem.
All under one roof. And the third point, customer retention, is arguably the most brutal. This one is aimed right at the hyperscalers.
Google, Amazon, Microsoft.
Okay.
We're all building their own custom chips. Google's TPU, AWS's Inferentia?
Exactly. NVIDIA has to give those customers a superior alternative to their own in-house stuff. They have to make sure they remain the primary compute partner. Groq's LPU is that superior alternative. It's an insurance policy to stop their biggest customers from leaving.
Okay, let's talk about the deal's execution. This wasn't a standard acquisition. Our analysis shows it's a very tactical asset plus talent deal.
Oh, absolutely. It's a masterclass in exploiting a regulatory loophole. The critical move here is that the Groq Cloud service, the business that serves existing customers, it's actually remaining independent.
Wait, hold on. If the business is independent, how does that work? How can Nvidia pay $20 billion and not own the whole company?
That's the tactical genius of it. NVIDIA secures total, immediate control over what really matters. The core IP, the chip designs, the engineering teams, that's the real treasure. They're leaving that small Groq Cloud entity independent to serve existing customers and, give the appearance of a competitive market. For now.
So it's a delay tactic. But if regulators in the US and EU are already watching these acqui-hires as stealth acquisitions, won't they just intervene anyway?
They might, but traditional merger reviews are triggered when you acquire the entire business and its market share. By structuring it as an asset and talent deal where the consumer-facing service stays technically separate, they bypass the normal thresholds,
So they grab the tech advantage now and force regulators to play catch-up later.
by which time the integration will be complete, making it much harder to undo. They've essentially bought the technology while insulating themselves from immediate antitrust action.
That's an incredibly aggressive strategy, cementing their power across both software and now specialized hardware. So what does this mean for everyone else in the market?
It creates instant, massive ripple effects. For the traditional giants like AMD with their MI300X or Intel with Gaudi 3, the pressure is now dramatically higher.
Because Nvidia isn't just a GPU company anymore.
Not at all. They're signaling they're going to own the specialized inference ASICs market too.
Yeah.
They've just moved the goalposts for the entire industry.
And what about the other startups, the ones Groq was leading?
They are in a very precarious position now. Companies like Cerebras or Sambanova, they basically have two choices. Find massive scale and find it incredibly quickly, or partner up with a hyperscaler like Google or Microsoft just to survive. The market has instantly consolidated.
Looking ahead, we have a pretty clear timeline for this new integrated tech. The first NVIDIA Groq hybrid systems could hit the market as soon as 2026.
And those systems will immediately go after the high-stakes, low-latency applications, the stuff that just cannot tolerate a millisecond of delay.
High-frequency trading.
Real-time translation services, advanced robotics, autonomous control systems, all of that.
And beyond 2026, this integration, it really accelerates the transition from the simple chatbots we use today to what? Truly autonomous, real-time agentic AI.
That's the end game. The speed advantage from the LPU is what's fundamental to making intelligent agents work instantly in the real world, reacting to things without any perceptible delay.
But we can't talk about a $20 billion bet without talking about the risk.
And there is one major risk that all the analysts and investors point to: execution risk.
This can't be overstated, can it? You're merging two fundamentally different philosophies.
Exactly. The LPU's data flow architecture is radically different from the GPU model that CUDA was built for. Integrating that seamlessly and efficiently into the colossal CUDA software stack is a huge technical challenge.
CUDA has to evolve to support this new architecture.
It has to. And if that integration is delayed or if it fails to capture the full speed advantage of the LPU, that $20 billion could start to look very expensive very quickly.
So to summarize this whole monumental investment, it's a textbook example of a market leader preemptively disrupting its own business. Nvidia is willing to cannibalize its own GPU market to secure that microsecond speed advantage for the next generation of AI.
It's a move that cements their dominance over the entire training to inference stack. They've shown they will pay whatever it takes to ensure the future of AI runs entirely on their silicon through their software.
And as we close this deep dive, we want to leave you with one final provocative thought. This connects this massive corporate deal to the wider geopolitical landscape. The consolidation of Groq's IP by Nvidia, a U.S. company, it really strengthens the U.S.-centric AI hardware stack.
Significantly.
Which raises an important question for you, the learner. What does this deal imply for global silicon sovereignty, and how will it force other nations, especially those trying to achieve technological independence, to accelerate their own internal chip initiatives in response to this American consolidation?
The race for real-time intelligence is now intrinsically linked to national technological independence. It's really a question of who controls the speed of the future.
Something critical to mull over as we accelerate into this new era of agentic AI. Thank you for joining us for this deep dive into the inference pivot.